All right, let's get into it. There is a huge strategic battle happening right now that is literally going to define the entire future of humanoid robots. And it's not about stronger legs or better hands. It's a fight for the robot's brain. It really all comes down to a question that sounds so simple on the surface. How do you teach a robot to organize a room? But that question, well, that's one of the hardest problems in technology today. And your answer reveals everything about your strategy for building the future. And right now, the industry is split between two totally different answers. On one side, you have the one big brain camp. They believe the solution is a single, giant AI model that sees the world, understands your command, and just acts. But on the other side, you have the toolbox camp. They're saying, no, you need a collection of different specialized systems that work together, where each tool is an expert at its own little job. Now, why does this debate matter so much right now? Because this isn't science fiction anymore. We've turned a corner. Humanoid robots are actually becoming commercially ready. The cost of parts is dropping, manufacturing is scaling up, and that means figuring out the right brain for these machines is suddenly the most important question in the entire industry. So, this really brings the whole industry to a major crossroads. It's a fundamental debate, and it's shaping the future as we speak. To make this concrete, let's look at two key players. In one corner, you've got a startup called Spirit AI, and they are betting the entire farm on that one big brain model. And in the other corner, you have a more established company, Unitree, and they're arguing for a much more cautious hybrid approach. Their disagreement really gets to the core of the whole problem. Okay. So let's unpack Spirit AI's big bet on this one brain idea. It's all built around a technology called a vision language action model. You'll hear it called VLA for short. So what is a VLA? Well, the core idea is to wrap everything up into one single system. It uses vision to see and understand the world around it. It uses language to parse a command like, hey, organize this room. And then it directly generates the action, all the little motor commands to make the robot's limbs move and get the job done. It's designed to be one seamless, flowing process from start to finish. And you can see why this is so tempting, right? For you, the user, it feels totally natural. You just talk to it. For the developers, it's actually really good at breaking down big, complex tasks. Plus, it's way faster to improve if the robot is always working in a similar, predictable place, like a hotel lobby. And honestly, it's just a simpler, cleaner system to build and maintain. And this is where Spirit AI's strategy just clicks into place. Their CEO has said they're focused on elder care, specifically inside a person's home, what he calls a nearly fixed space. And for that very specific controlled environment, the VLA model's strengths, well, they look like a perfect fit. But that's the promise inside a nice, neat, controlled box. Unitree's big argument is that the second a VLA-powered robot steps out into the messy, chaotic, real world, its limits become a huge problem. The founder of Unitree was incredibly blunt about it. He just said the VLA architecture is too limited, and he thinks this isn't just a minor bug you can fix with more data. No, he sees it as a deep, fundamental flaw in the whole approach. So what are these real-world flaws? Well, for one, these models can get really unreliable when they see a messy room for the first time. Their fine motor control is often, let's say, brittle. Think clumsy, jerky movements. And teaching it a new skill, it's not so simple. You might have to retrain the entire massive model, which costs a fortune in both time and the expensive computer chips you need right there on the robot. But what does too limited really mean in the real world? Especially when you're talking about situations where millions of dollars or even people's safety are on the line. The author of our source material gives this really powerful personal example. He talks about having to walk away from a $7 million deal for a robot that was supposed to explore mines. And the reason? The robot had to navigate a completely unknown, unpredictable, chaotic environment. It was the perfect storm of real-world problems that today's tech, VLA included, is just not reliable enough to handle. And this really gets to the core of what Unitree is trying to do. See, they aren't just trying to solve for one fixed space. They want a robot that can walk into any living room, in any house, anywhere, and reliably figure out how to organize it right there on the spot. That's the holy grail of general-purpose robotics, and they argue VLA by itself is never going to get us there. So, if VLA alone isn't the answer, what is? Well, this brings us to the hybrid path.
an approach that tries to take the best from both the big brain and the toolbox philosophies to build something much more powerful and reliable. Let's break down how this toolbox would work. Step 1. You actually still use a VLA, but only for the high-level thinking, to understand the command, organize the room. Step 2. The system then calls up separate, specialized tools for specific actions, like a super reliable pickup cup controller. Step 3, it pulls these skills from a whole library of pre-trained abilities. And for step 4, it can even run a quick simulation to test out an action in a virtual world before it tries it for real.
Now, one of the key tools for making this hybrid future happen is advanced physics simulation. The idea is to build these amazing virtual worlds where a robot can practice and test things safely. The upside is obvious. You get much better physics, and you can transfer skills from the simulation to the real robot way more efficiently. The downside? Well, these things need a ton of computing power, and it's going to take a while before they're easy to just plug into a commercial product.
So you've got these two competing ideas, all this complex tech. What's the actual winning playbook here? How does a company navigate all of this and actually succeed?
The smartest strategy, it seems, isn't to pick one path. It's to do both at the same time. You can see it laid out here in this dual-track approach. In the short term, you push hard with a VLA model in controlled spaces, like elder care, to prove you can make money and deliver value right now. But in parallel, you make that long-term investment in building the robust, hybrid architecture, the one that will eventually let you tackle the entire, messy, general-purpose market.
So the big takeaway isn't about choosing Team VLA or Team Hybrid. The winning playbook requires pursuing two paths at once. You've got the sprint, which is all about generating revenue and proving the concept today. And then you've got the marathon, which is about building the foundational tech you need for total market dominance tomorrow.
So the stage is set. You've got Spirit AI sprinting down that focused VLA first path, betting they can win a specific market and win it fast. And at the same time, you have Unitree patiently building this more complex hybrid system, getting ready for a much bigger general-purpose future. Make no mistake. The robot revolution is coming. The only question left is, which of these two strategies, the focused sprints or the patient marathon, is going to be the one that finally unlocks it for all of us?